Welcome to Ask and Learn.
Hey, it's Clarissa and Numeraid here. So we're going to do a proof. So we have a given, and by the definition of the big theta notation, f1x is og1 of x, and f1x is omega g1x, and f2x is og2x, and f2x is omega g2x. By the definition of the big O notation and the big omega notation, there exist constants k, c1, c2, c3, c4, k1, k2, k3, k4, and such that f of 1 absolute value is less than c1 absolute value g1x whenever x is bigger than k1. This goes the same for this is bigger or equal to c2 absolute value g1 of x whenever x is bigger than k2. This one's f sub 2 x absolute value is less than or equal to c3 g sub 2 of x, and this is whenever x is bigger than k3. And we have absolute value of f sub 2 of x is bigger or equal to c4 absolute value g2 x whenever x is bigger than k4. So let k equals a max, k1, k2, k3, k4, and let x be bigger than k. So we have absolute value of f1, f2, parentheses, and x, which is equal to the absolute value of f1 x times f2 of x. Then this becomes equal to the absolute value of f1 of x times absolute value of f2 of x, which is less than or equal to c1 absolute value g1 of x times c3 absolute value of g2 of x. And then this becomes equal to, after we simplify, absolute value c1, c3, g1, g2, x, absolute value. And we have the absolute value of f1, f2, and x is equal to the absolute value of f1 x times f2x and this is equal to absolute value of f1 of x times absolute value of f2 of x. This is bigger or equal to c2 absolute value g1 of x times c4 absolute value g2 of x. Simplify this, we get c2, c4, g1, g2, x. And by the definition of the big O notation, f1, f2x is O of g1, g2x with constants k equals max, k1, k2, k3, k4, and c equals c1, c3. By the definition of the big omega notation, f1, f2x is omega g1, g2x with constants k equals k1, k2, k3, k4. This is within the max, and c is equal to c2, c4. So by the definition of the big theta notation, f1, f2x, f1, f2x is then theta g1, g2